Good afternoon, class. Today we'll be taking chemistry. Yeah, our topic for today is water. Chemistry, women, formal spelling is chemistry. We should all know what water is. Water is a colorless, odorless, and tasteless liquid according to our primary school definition. They said water is a colorless, odorless, and tasteless liquid. Yes, that's actually the correct and basic definition of water. It is colorless, it is odorless, and it is a tasteless liquid. Any other thing, anything that has taste, that has odor, or any color, it is no longer water. Another thing has been mixed with it. So let's move on. Water is very essential. Over 80% of Earth's surface is covered with water. Over 80% of Earth's surface is covered with water, and 70% of human body is also contains water. For you to know how essential water is very important for our day-to-day activities, for digestion, for everything we do, for human life. It is very, very important. So now let's move to the types of water. That's all about water. You know that water is a colorless, odorless, and a tasteless liquid. And don't forget, 80% of the Earth's surface is covered with water, and 70% of the human body is also covered with, also contains water. So we have different types of water. We have two types of water. We have the natural water and the artificial water. Natural water and the artificial water. Please note this: water is a universal solvent. Note, water is a universal solvent because it dissolves almost all particles. That's why it is noted to be a universal solvent. Now, the types of water: we have natural water and the artificial water. What do we mean by natural water? You should know what natural is. Natural is anything that comes from God. So, natural water are waters that come from God. Example is rainwater, the well water, the waters from the river, the water from the river, the water from the ocean, the water from the sea, and any other form of water that is natural, that is God-made. That is the meaning of natural water. Please note this: the purest form of natural water is rainwater. Example, rainwater, well water, spring water, another type of river, the water from the river, from the sea, from the oceans. These are examples of natural water. And the purest form of natural water is rainwater. This is the purest form of natural water. Why is it the purest form of natural water? It is the purest form of natural water because it is formed from condensation. It is formed from condensation. It is formed from condensation. I think you know what condensation is. After evaporation, the next is condensation. Let me give you an example. When you pour water on the floor, or example, our seas, they are open water surfaces. When the sun is shining, it does what? It evaporates the water. After evaporating the water gets up and goes there to condense. So that is the meaning. That is what gives us rain. After the condensation, then comes rainfall. So rainfall is the purest form of natural water because it is formed rather from condensation. It is formed from condensation. That is why it is the purest form of natural water. So now let's move to artificial water. We all know what artificial is. Artificial water is man-made water. The water we made ourselves. Example is distilled water. Distilled water is the only important example of artificial water. This is where we have distilled water. I think we all know how distilled water is formed. Distilled water is formed in the lab. So it is formed from evaporation of the normal water and condensing it. So it is a very pure form. It is also the purest form of artificial water. Distilled water is the purest form of artificial water. Distilled water is the purest form of artificial artificial water. Why is it the purest form of artificial water? Because it is also formed from condensation. After water has been evaporated, then it's later what? It is condensed. That is where the sewage water is formed. From. So the sewage water can be used in medicine. It is used to produce drugs. It's also used in industrial chemistry. Those are the uses of the sewage water. So now let's move to the structure of water. This is chemistry. We are done with types of water. Now let's move to the structure of water. Structure of water. Now let's draw the derivative structure of water. Water is H2O, as we all know. H2O. So now let's look at how water is formed. Hydrogen plus H2 plus O2 is equal to H2O. Let's balance the equation. How many moles of hydrogen is needed there? We have 2 here, we have 2 here. The oxygen is 2. You can't add anything here. It is impossible. Balancing of chemical equation, that is not the way to balance it. The only thing we can do is there is 2 here. We add 2 here. The 2 will affect the oxygen here, and we have 4 hydrogen. So we have 2 moles of hydrogen with 1 mole of oxygen equals 2 moles of water. 2 moles of water. This is the way water is formed. The structure of water, H2O. Oxygen is the central atom. So oxygen is here. It goes. This is hydrogen. This is hydrogen. There is a bond here. There is a bond here. There is another one here. There is another one here. Which means 2. To complete it, 2 can be here. Which means 4 rather. Here. So this is the shape of water. The shape of water is tetrahedral. Tetrahedral. The shape of water is tetrahedral, and water has a bond angle. Please note, bond angle of 105 degrees. The shape of water is tetrahedral. The shape of water is tetrahedral, and it has a bond angle of 105 degrees. 105 degrees. To 6 Celsius. So I think we get this. Water is formed from 2 moles of hydrogen, 1 mole of oxygen, equivalent to 2 moles of water, and the shape is what? Tetrahedral, and the bond angle of water is 105 degrees. That's the bond angle of water. How is that the structure of water? So now we move to the next. Hardness of water. This is one of the properties of water. Hardness of water. This is the exact reason why we are taking water in chemistry, for us to know the principle behind how the water is being hard or soft. Hardness of water. Hardness of water is one of the properties of water. When the water is hard, the water doesn't form lather and soap. That is just the meaning of hardness of water. Hardness of water is the property of water that makes it not to form lather. Foam. Oh, yeah, by lather with. I said lather with foam. Not to form lather with soap. What do I mean by lather with soap? When you are using your soap and it's not foaming, the foam is what they call lather. So when you are using water and you are using soap, maybe you want to wash or do anything and it's not forming lather, notice that the water is hard water. What is the cause of hard water? Hardness of water is caused when water is pronounced, let's just put it like this. Water is pronounced to be hard when it contains calcium and magnesium ions. Water is pronounced to be hard when it contains calcium and magnesium ions. So the cause of hard water is calcium and magnesium ions. What are these ions of calcium and magnesium that causes hard water? The CaSO4, MgSO4 is also one, and CaHCO3 2. So these are the causes of hard water. This is calcium tetraoxosulfate 6, magnesium tetraoxosulfate 6, and this is calcium hydrogen trioxocarbonate 4. These are the causes of hard water. These three ions are the major causes of hard water. How does the water become hard? How does it become hard? When any water passes through a soil that contains Ca, when water passes through a soil that contains Ca3, this is calcium trioxocarbonate 4. It's called Ca3. I will use Ca3 more so that it will be fast to the class. Ca3 is calcium trioxocarbonate 4. When water passes through calcium trioxocarbonate 4 plus H2O, look at what it will give us. It will definitely give us Ca. Please note that calcium trioxocarbonate 4 is not really soluble in water, but when the water is exposed to air, we have abundance CO2. I think you understand. Calcium trioxocarbonate 3 is not soluble in water, but because the water is open to air, there is CO2, and CO2 will make it soluble. I think you understand. CO2 will make it soluble, so that is when we have CaH plus CO2. When CO2 is present, this is what happens at the end of the day. I think it is when Ca3, H2O and carbon 4 oxide, when they combine together, it gives this. And when the water contains this, the water will become hard. This is just a simple equation of the reaction. Now, okay, another way a water can become hard is when it comes in contact with any soil that contains CaSO4 plus H2O. This is another way water can become hard. So aside this, there is another way water can become hard. So now we have two types of hardness. We have the temporary hardness and the permanent hardness of water. The temporary hardness of water and the permanent hardness of water. We have two types of hardness. We have the temporary and the permanent hardness. Temporary hardness and permanent hardness. What is just the difference between these two types of hardness? The only difference is that this one is caused by CaHCO, calcium hydrogen trioxocarbonate 4. That is the cause of this one. While this one is caused by CaSO4, calcium tetraoxosulfate 6, and MgSO4. Magnesium tetraoxosulfate 6 also. These are the causes. These are the two differences. And another difference between the temporary hardness and the permanent hardness is that temporary hardness can be removed by boiling, but permanent hardness cannot be removed by boiling. So one of the major differences between temporary hardness and permanent hardness is that the ion of calcium that is causing this one is calcium hydrogen trioxocarbonate 4. And the one causing permanent hardness is calcium tetraoxosulfate and magnesium tetraoxosulfate. So the sulfate ions are the one causing permanent hardness, while the trioxocarbonate ion are the one causing this temporary hardness. So now let's move on. Let's talk about temporary hardness. How temporary hardness can be removed. The first step by which temporary hardness can be removed is by boiling. B-O-I-L-I-N-G. Boiling. So what is the salt we want to decompose on eating? It is what? What is the salt that is causing temporary hardness? CaHCO3, calcium hydrogen trioxocarbonate 4 is the ion, the salt rather, that is causing temporary hardness. So when it is boiled, on eating it decomposes. So this is it. You have CO3, 2. The delta is it. So when it is heated, this also what? CO3 plus H2O. Then it gives Ca3 plus H2O and also plus CO2. What do you mean by this? So is this equation balanced? Let's say carbon, hydrogen, okay. Hydrogen here is 2, and here is also 2. The oxygen here. So like this, we should have a balanced equation. So now let's move on. When this one is heated, it does what? It breaks down and gives us calculative. We all know, I said earlier, that calculative is insoluble. This is triazocarbonate of group 2 elements. Triazocarbonate of group 2 elements are insoluble in water. They are insoluble in water. So when this is formed, then we have our water and CO2 is given out to the atmosphere. This is one of the ways to remove temporary hardness. And another way of removing temporary hardness of water is by adding slakes lime, calculated amount of slakes lime. Please note, so adding addition of calculated amount of slakes lime. And slake lime is what? CaOH. This is the formula for slake lime. Slake lime is another addition of slake lime is another way for removing temporary hardness of water. So how is this done? You know the salt that causes temporary hardness is what? CO3 plus CaOH. So definitely we are having calculative again, which is what? Insoluble. Okay, calculative is formed plus water plus CO2. You can get yourself a balanced equation. So this is just the basic of the reaction. This is how the reaction will occur. Don't forget that this is insoluble. So triazocarbonate of group 2 elements are insoluble in water. It is formed between the soluble in water. You have your water part, and the CO2 is given up to the atmosphere. So that is all about it. Why I said it was a calculated amount is because when you add excess slake lime to temporary water, the water becomes permanent. Please note this: when excess slake lime is added to a temporary water, in order to remove the hardness, the water becomes permanently hard. So the slake lime we are adding must be calculated. So that's all about temporary hardness of water. Let's move to permanent hardness of water. Permanent hard water rather. Permanent hard water can be removed by any other means aside addition of chemical or sometimes distillation. But most times it's the addition of chemical. Addition of chemical is the only one that's economical. It's the only one that is okay. So we have some processes to remove permanent hardness of water. First one is distillation. Second is addition of washing soda. Okay, addition of washing soda. And 3 is addition of NaOH, this baking soda, and the other one is addition of this Pamutis method. Let me just say Pamutis method or Pamutis method. This is an ion exchange method. So now let's go. Washing soda is 2, 3. So distillation is one of the ways of removing permanent hardness of water. Permanent hardness of water. One of the ways to remove permanent hardness of water. By doing what? By putting the water down, by heating the water, make it evaporate, and then condensing it. That is one of the ways to remove hardness of water, permanent hardness of water. But this is not advisable because it's time wasting and it is not really effective. But the effective ones are addition of chemicals. When chemicals are added, one is addition of washing soda. What are the ions that cause the salts rather that cause permanent hardness? We have CaSO4 to be among. So CaSO4 plus Na2CO3 So you definitely permit me to print some of the stuff written here. So we have CaSO4 plus Na2CO3. Then what do you expect us to have? We have CaCO3 again, which is insoluble, don't forget, plus Na2O3. So this will be the basic of the reaction. The reaction equation is not balanced. You can balance. Okay, Na2SO4. Sorry, Na2SO4. So this is the basic of the reaction. You can balance the equation on your own. So this ion of calcium, this is okay. Let's just say calcium tetraoxosulfate 6 plus sodium triazocarbonate. Plus sodium triazocarbonate, which is also known as washing soda, will now give us capital 3. Don't forget, I said triazocarbonate of group 2 elements are insoluble in water. So it will be soluble in water. Then we have this Na2SO4. That is all. The hardness of that water is removed. The hardness of the water is removed. And the next one is addition of what? Addition of NaOH. NaOH plus CaSO4. Or let me just use the magnesium here. MgSO4. Plus this true. So we can add this true to the other equation. So this true has to be there. Now, NaOH and MgSO4. Triazocarbonate of this is the other reaction for removing the second hardness of water, permanent hardness of water. And the last one, which is the ion exchange method. The ion exchange method is used when we have a lot of water, when the water is much. Let me just say that. It is used when the water is much and it is economical. Like it can be regenerated. The sodium zeolite which is used can be regenerated. For the Hammond's method, the main process is by ion exchange. There is exchange of ion, and the major chemical we are using is sodium zeolite. Sodium zeolite. So when we send sodium zeolite as NaP. So now we have CaSO4 plus NaP. And then what are we going to have? The exchange of ion. So we have calcium zeolite plus NaSO4. This is just the simple way. This is just the way the ions get exchanged. And there is also something about this Hammond's method why it is very economical. It's because the sodium zeolite can be regenerated when salt is added. Our normal table so it is NaCl. When it is added, the sodium zeolite can be regenerated. So CaP plus NaCl, which is our common salt. So the ion is exchanged again. We have sodium zeolite NaP plus what? CaCl, calcium chloride. So this is just the equation for the Hammond's method. It is an ion exchange method. It is carried out in ion exchange resin. That is where it is carried out. This is where the Hammond's method is carried out. It's just an ion exchange method. There is exchange of ion between the two compounds. That is just it about that. So now let's move to properties of water. So one of the properties of water is hardness. Physical properties of water. This is chemical property of water. This is hardness of water. Let's go to the physical properties of water. According to our definition of water, we said water is colorless, odorless, and tasteless. So our first physical property will be what it is: colorless, it is odorless, and it is tasteless. Number two, another physical property of water, it has a boiling point. point of what? The boiling point of water is 100 degrees Celsius, and the melting point of, let's just say, freezing point. Freezing point of 0 degrees Celsius. Another property of water is that it is neutral to litmus paper. Another property is that at 0 to 4 degrees Celsius, it exhibits an anomalous behavior. At 0 to 4 degrees Celsius, it exhibits an anomalous behavior, which is abnormal. It's an abnormal behavior of water, whereby at 0 to 4 degrees Celsius, it expands. This is an abnormal behavior of water, whereby water expands at the temperature of 0 to 4 degrees Celsius, unlike other liquid that contrast at that temperature, but water expands at this temperature. This is one of the physical characteristics of water, or properties of water. Another property of water is that it has a pH of 7, that is why it is neutral to litmus paper. So now let's move to some uniqueness of water, some of the uniqueness of water. Basic uniqueness of water. Why is water unique? Unlike all other liquids, their solid is heavier, but water, the solid of water is less dense. Let me just use less dense. When you hear the word dense in chemistry, dense means heavy. So unlike other liquids, whereby their solid is heavier, but water, the solid for water is less. It is not as heavy as the liquid form. Why is it like this? It is like this because the force of attraction on the solid is not much to that in its liquid form. No, the bond in water is hydrogen bond. This is the type of bond we have in water. So the hydrogen bond the way the hydrogen bond in the solid form is less to the way the bond in the liquid form. That is why the solid form is not heavy and the liquid form of water is heavier. I hope you understand that. So now let's move to the second uniqueness of water. It is its melting point and its boiling point. For a liquid that looks like water, that is as simple as water, is not supposed to have a melting or a boiling point as far as what it has. Our melting point our freezing point for water is 0 degrees Celsius. It's not supposed to be up to that, and for a liquid of its type. But because of the hydrogen bond in it, that is why we all know hydrogen bond is a weak bond. But because of this hydrogen bond, that is why it is having something as high as that. Another uniqueness of water is that it expands from 0 to 4 degrees Celsius, which I call the anomalous behavior of water, or the abnormal behavior of water. This characteristics of water, or this uniqueness of water, has its own advantage and disadvantage. Its advantage is that when water expands at this point, it makes the rocks on earth, it makes them break, and when they break, they fertilize our soil. The disadvantage of this property is that at 0 to 4 degrees, when water is expanding, it makes the tissue of plants and animal cells, it makes them burst, because I told you earlier that the human body has 70% of water, and plants also, sure, they will have some water in them. So when this is happening at 0 to 4 degrees Celsius, when water is expanding, their tissues will start to burst. That is one of the disadvantages of the anomalous behavior of water. So now let's move to the next, which is test for water. Test for water. When water is added to cobalt 2 chloride, blue cobalt 2 chloride, it changes to pink. It changes copper to chloride from blue plus water. Changes from blue to pink. Blue to pink. So another property of water, another test for water is when white anhydrous copper sulfate is added to water, it changes from white to blue. White anhydrous copper sulfate changes to blue in the presence of water. Let's just put it that way. White anhydrous copper sulfate changes to blue in the presence of water. So these are the easiest way and the simple way to know that okay, this thing has water and this thing doesn't have water in it. When you add copper to chloride paper to any surface and the surface changes from blue to pink, then the paper changes from blue. Naturally, copper to chloride is the blue paper. So when you add it to any surface and the surface changes to pink, that is to tell you that that surface has water in it. That surface contains water. And when you have anhydrous copper sulfate, it is also white when you put it to any surface of any substance and the substance changes to blue, that is to tell you that the substance or the surface has water in it. So now let's move to advantage and disadvantage of add water. Advantages and disadvantages of add water. One of the advantages of add water is that it is good for drinking because it has a lot of minerals, a lot of salt dissolved in it, and it helps arthropods also, which are the crabs. It helps them to develop their shells. Snails also, it helps them to develop their shells because of the calcium and the magnesium present in it. Another example of add water is that it does not cause lead poisoning. When it is passed through lead pipe, it does not dissolve lead in it. But when soft water is passed through lead pipe, it dissolves lead and it causes lead poisoning. So now let's move to disadvantages of add water. One of the disadvantages of add water is that it causes wastage of soap. Another disadvantage is that it is not good for dyeing and tanning because the salts in it interfere with the compounds, with the composition of the dye and whatever you want to use. Another disadvantage is that it makes white clothes, it makes them dull because of the compound, because of the ions of magnesium and calcium that will be deposited on the clothes. So it makes white clothes or white fabrics, it makes them dull. So that is all about the advantages and disadvantages of add water. I think that is all about water. We talked about the structure of water, the properties of water, the chemical properties and the physical properties of water, and now the test for water and uniqueness of water. This is all about what water is. Thank you for listening.